Welcome to a new test and teardown video. This time we're going to look at a power supply. This one is from a French company called Metrix ITT. And then, yes, of course, power supply T3 935A. So I believe what we got here is 4 individual power supplies where you can adjust the output voltage quite accurately and high resolution using those. This one is the only one that can turn, by the way. The others, they are like very stuck. There is a little locking and release mechanism here. And I believe maybe that is what is the problem. They're all this impossible to move. But let's just play along with this one that is moving so good. I've been massaging that one quite a lot. So let's imagine all these 8 power supplies, they're completely individual. And maybe it works like this. So the output goes via this switch where you can reverse the output polarity, and then it goes to these 2 banana jacks here, right? So that will be the ground in case you are in negative, and the other way around, right? So I assume that you are here and you can take this output voltage to somewhere else, right? Or you can connect this little output goes to somewhere else kind of connection, right? And then I believe it goes to this switch. And then you can easily dial between or select between all the different 8 voltages to this output. And then there's even a little monitor here that goes from 0 to plus minus 10. It don't really say plus minus here, but I kind of figure that out. And then there is this funny plug-in. I haven't yet figured that out. Maybe we should start investigating what is that doing. That is quite funny. So it's some sort of a scaling board where you could put in all those resistors for scaling to something else. So it could be, you can imagine this being plus minus 10, 1 or millivolts or whatever kind of. Yeah, so that is some sort of scaling, and nothing is connected. And that's all there is to it. So, well, okay. I'll just put it back together again, and then we will have to look at the back, because I think there's probably a remote control option. I am getting more and more confused about this. So we get 2 fuses, 1 amp and 2 amp. We got some different voltage settings, and it seems like that is correct for 20 to 30. We got a power on-off switch here that is a little bit dodgy. Okay, so on is up. Remote. Aha, see, there is some sort of remote, right? Interesting. And here is the label. Metrologique. Okay, so this is from France. And the type number and all that kind of stuff. But what do you make of this connector? Power supplies. So maybe this is a remote interface for external power supplies. So that means maybe we don't have any power supplies in this one. Maybe this is just a remote control rig for external power supplies. Or maybe this is outputs from all the power supplies. I mean, we need to open this thing and see for ourselves. Oh, did I say it is quite heavy? It is 17.2 kilos. So that is why I had the idea it could definitely contain power supplies. It is getting more and more interesting here. Look at those big transformers down here. Let's get some light. So we've got 2 of them. And that explains the heavy duty 17 kilos. I need a flashlight here to show you all the capacitors all the way down here, right? So that will be the wires from all the front stuff. Here at the front, we just got all the set points, and it looks like they're sharing the same kind of rail, right? So they can't be floating. Otherwise, I need to inspect how is this really designed, because all the settings here, they're just in parallel, as you can see with this, right? And this is the positive negative, where you switch between positive and negative, and then it goes to the endpoint of your potentiometer. So that means this one's probably plus minus 10 volts, right? And then you adjust between ground, and then this is your output, and this goes back to the controller driver board, and those are down here, right? We got 8 of these, and you see some transistors, power transistors and such down there. We got some, I don't know, a common logic board of some type, and all the red capacitors, as you see here, we see 3, 4 of them on each of these 2 boards, and down here we got some more boards, and again more and more capacitors. So if I'm not mistaken, we get all 8 sets of capacitors just located a little bit here and a little bit there, right? And again, some main power supply stuff here. It's really beautifully made. Look at the cables and the way that they're using shielded cables here. That is the big beast of the main power supply, and all outputs again carefully, nicely shielded like that. So they mean business. I think this is some reference calibration, something quite serious and quite nice, really. Internal potentiometers here, probably to set the plus minus reference voltages, most likely, because I see only 2 of them. And then they go down, maybe they go down to the first one. This is probably the one that is making the 2 reference voltages. See, all those rectifier diodes all the way around. So since this transformer is this big, and this one is this big, and all those big hefty diodes, and yeah, everything looks quite big. Oh, we got some more heat sinks and power transistors. Okay, we got 2 power transistors on each. 1, 2, 3, 4, 5, 6. So we need some more, maybe. All those boards, they're carefully screwed. I don't know if that is super visible here. You see there's a little screw that goes to the bottom. But I think I dare to power this up and see what happens. So I feel lucky. This is the one with the dial that is working. So I put my voltmeter there, and I dialed it for 030. Then we're gonna see what is going to happen. And yes, I got chassis connected to protective earth. So I do dare to plug it in, and let's see what happens. There isn't any light or any thing going on. It was 30 watts, 40 watts, and it's going, watts, they're just going down 20 watts. And we got minus. Oh, it is because it sets for minus. But why is the power just dropping and dropping? This is weird. Positive. So this is definitely voltage, right? But why was it 40 volts? And then, okay. So 1 and then 0, 0 on the dial gives me 1.00 volts. That is quite impressive. And still, power usage just drops and drops all the time. So this output is called V0, and there is a switch here. So my idea is, let's see what happens if I plug it up here. That is V1, right? So I go down to, it was all the way down here, right? V0 is my, probably I forgot to put in this one. No, but why is the voltage a little bit lower? Yes, it is the same. It is the same voltage, but it is now a little bit lower on this output. So that is voltage 0. My idea is if we plug in here, yeah, we could reach. Ooh, that is floating. Or something is going on. And then we can measure here, and then we have our 1.0 volts. Okay, so there's probably just an output voltage power driver or something that is not super accurate, but the set points here, that's definitely super accurate. That is a little bit interesting. And this voltmeter here, now we are here. Okay, that is the monitor of what we're doing. And if I crank it up here, see? The voltmeter also works. And if I put this for 999, I get 10.0 all the way up here. So this is okay. Quite some voltage generator, calibrator, supply kind of thing. And it really works and is super accurate. But what can I use this for? I need to figure that out now. I think this is a very impressive view here from the bottom. Wow, we can really see everything so much better. I pulled out one of the power supply modules. I believe these two are individual or exactly the same. And then we have exactly the same going on this circuit board here. It just goes on and on and on, and it's the same circuit like this. That's just repeated. It's a little funny the way that this is solved, but maybe it has something to do with the kind of size, and we want the transformers over there, and so what. Let's first look at this little power supply unit here. See, there's a few small signal transistors and a current sense resistor. I believe the output current goes through this one, creates a voltage drop that turns on something, and then that turns off the output. So this one is probably a pre-driver or the output sort of transistor for that. It's 2N2905. And yeah, quite a lot of capacitors, by the way. That's a little bit funny, isn't it? Let's look at the next one of these. So we got an output transistor here, and then we got, we got two output transistors and a 741 op amp. Look how old this is. Sometimes you find date codes on the op amps, but I think we need to look at this. And this is probably the plus minus 10 volt op amp system. And that one, they are also using 741s. It's a little bit funny the way that the footprint is made, right? So you can have both the dip type or the can type. This board can support both of them, as you can see here. And the 741s, they got date codes 70. And also the other one is also a 741 that is also from 1970. So I'm a little bit shocked to find out that this unit is that old. I was thinking between 70 and 80, but not 70. I was hoping for in the middle, but so I just guessed wrong. Look at those test points here. So they are both VS and test points. So this is a double-sided board with just those tiny little tracks here. And I believe this is the only double-sided board. The rest, they are single-sided boards like this with nice silk screen and all things nice. What do you know? So that is what this unit is doing. Now I'll try and see if I can figure out how to say, yeah, this one was the good one, yeah. Probably I just need to take off the knob first, and that will probably give me access. Oh, maybe this is the secret access. That thing in there. We are not supposed to see what is going on there. That one. Yeah, this one. Let's attack this one. Soon I should be giving some advertisement money. I think so. That will be on its... Contact 61 saves my day once again. Just a few drops down in this little slot here. And then I could start to move the lock. And then once the lock was moved, I could still not move the dial. And then I dropped a little bit more in here. And now it's just pure magic. And that was in like 20 seconds. That is what it took to super fix this. But I still want to know how to get in here, by the way. I just think I did something real stupid because I wanted to see how we get in here. I released those two screws here for the knob itself because I thought I could get this out first and then I could maybe get some access to something. But the whole thing is, this is what holds the entire mechanic readout and all that kind of stuff. This is just the shaft, and this little slot or this little hole here align with this hole, and this is why they are a little bit like that. So you just put them on and then clickety click, and then that is how it's supposed to go. And now I have, of course, screwed up the calibration because now this shaft here is now not aligned to the readout anymore. But now I can clean this up real nice and beautiful. See, the front thing is to say Faircon DFD here on the front, and it says Fairchild Controls on the bottom, Hicksville, New York. But then, made in Japan. How funny is that? But it's a very, very good system here. There's no slippity slappity or anything. It's just really, really good made, and there isn't any big, nasty. No. I'm probably gonna add a little more drops of goodies to this and see if it's probably not gonna go any better than this. It is super perfect. I really like this. Yeah, I don't know what else we can say about this unit, really. I don't think I want to say so much more. I have already said it all. That is my decision for tonight. So that means thank you for watching, and bye-bye, my friend.